Okay, in section 2.2, we're going to talk about histograms, frequency polygons, and time series graphs. Okay, so histograms are very similar to the bar charts we talked about in the last section. The bar charts are generally for qualitative data or things that we've put into groups, where histograms usually are dealing more with quantitative data. So they again are with boxes or bars. They have both a horizontal and vertical axis. Similar to the bar graphs, the horizontal axis is labeled with the data. For example, the distance from your home or your school. Sorry about that. And the vertical axis, just like the bar graphs, is the frequency or relative frequency. Relative frequency is like the percent frequency or the probability. We'll talk about that a little bit later. So no matter if we use just the frequency or the relative frequency, the shape will be the same for either one of those. And very similar to the stem plot that we talked about, we're going to look at the shape of the histogram. And so it'll also tell us a little bit about the center of our data and the spread of our data. But remember, the shape is so important because in descriptive statistics, we're collecting that data in a sample and we're describing it. We're giving the shape of it, the center, the spread, figuring out what our data looks like. And we're going to use, remember the importance with this descriptive statistics and the power of statistics is our inferential statistics. We're going to use this sample data to make inferences or draw conclusions about our population data. So population data, we don't need to collect all that data. We can use our sample data to draw conclusions or make inferences about the population data. And when we do that, we're going to use a lot of different techniques in the later chapters to do inferential statistics, and that's really the power of statistics. But we need to know there's some assumptions we make, and some of these assumptions is how is our data distributed or what's the shape of it. And so histograms are an easy way to tell us what the shape of our data is. Okay, so the first thing we need to do is determine the number of bars we're going to have. Oftentimes these are called classes, the number of classes we're going to have. So we also need to find the starting and the ending points. So the easiest way to do this is to go, we look at all our data and say how many decimals. If it's just a whole number, then we just go one decimal place. If there's one decimal point, then we go 2 decimal places. And I'll show you what I mean in this example here. Then we find, once we have our starting and ending points, we just find our class width or the width of each bar by taking that ending point minus the starting point and dividing it, this is the division sign, by the number of bars that we have. And then to get our frequency, we just count how many data points fall in that group. And then to get our relative frequency, we divide each one of those by our sample size. So let's look at an example here. Okay. So in this example here, we can see that the following data are the shoe sizes of 50 male students. The sizes are discrete data since shoe size is measured in whole and half units, but it is measuring, so it is quantitative data. So what we're going to do is construct a histogram and calculate the width of each bar or class interval. And we want to, here it does tell us that we're going to use 6 bars. Okay, so most of the example problems will tell you how many bars to have or how many classes. Okay, so remember, we want to determine the number of bars. We did that. We want to find the starting and ending point. So we look at our smallest number, which is 9, and we're going to use a convenient starting point, and usually that's just subtracting a half. But because we have we have half shoe sizes, we go to 1 decimal place, we want to have a convenient starting point that is 2 decimal places below 9. So our convenient starting point here is going to be 8.95. We're going to go 0.05 lower than 9. Does that make sense? And then our convenient ending point will end up being 0.05 more than 14 or 14.05. Does this make sense? Okay, so now what we're going to do is we want to calculate what our class width will be, or the width of each bar. So remember the way we did, it tells us to do that is take the ending point minus the starting point and divide it by the number of classes. Okay, so let's look at our calculator here. Bear with me. Let's do 14. So $14.05 minus 8.95. Now, because I didn't use parentheses here, I can't just say divide. If you want to do it in one step, we have to put parentheses around the numerator of our what we're dividing here. So I'm just going to do second insert here. So if you just start off, just use your parentheses here. And then we're going to hit divided by 6. That was the number of bars. So we get 0.85. So we're going to go ahead and just round up to 1. So we have a class width of 1. Okay, so with our class width of 1, we're going to, now remember, we do want to round up. I don't know if I emphasize this with you all. Even though we got 0.85, it's natural to round up to 1, but you usually want to round up even if you normally wouldn't have, like if we got 1.2, you want to round up to 2. Round up to the next integer so that we can make sure we include all the data values. Okay, but here we just round up for 1. So we're going to start our lower bound with our starting point of 8.95. And our upper bound, we're just going to add 1. Plus 1, we get 9.95. Okay, now these are called our boundaries. So they're going to touch. That's going to be the edge of our bars. So remember in our histogram, our bars always touch. So sometimes other books will do where we have class limits and they'll be a little bit different where they don't touch, and then you create these boundaries. So we're just starting right here with the boundaries. So our next one will be 9.95 to 10.95. So we just repeat that upper boundary down here. So 10.95 to 11.95, 11.95 to 12.95, 12.95 to 13.95, 13.95 to 14.95. So we have 1, 2, 3, 4. Those are our 6 bars. 1, 2, 3, 4, 5, 6. Make sense? Okay, now we're going to count our data values that fall in between each class. Now, this set of data is already in order. Okay, I'm going to show you just quickly here on your calculator how you could put this data set in your calculator. So on your calculator, the way we put a data set in is we go to, when you look at your calculator, your favorite button is going to be statistics, because this is statistics class, right? So that's my favorite button. Doesn't have to be your favorite button. I know some people will say their favorite button is turning it off, but mine is stats. My second favorite button here is math. So we're going to use my favorite button a lot. We're going to go to stat. Now when we go to stat on our calculator, we're going to have several options. We have edit, calc, and test. Our edit button is where we're going to put the data into what's called a list, and then we can sort it. So if our data wasn't sorted over here and we put it in a list, we could then sort it. And then other options are calc. There's some different things we'll do here. And then the tests are what we do with inferential statistics later on. Okay, so the first thing we just do is arrow there. Now, I will tell students to get out of this screen. This, see above the mode right here is quit. You do second quit. Will always take you back. I just call it the home screen where you can do calculations and whatnot. That was, again, that was second quit. Okay, all right, let's go into stat. And then we're just going to go to edit by hitting enter here. And this will give you these lists. And this is where you can type in data. So if you want, go ahead and type this data in. It's already in order, but let's say it wasn't and we went ahead and typed it in and we wanted to put it in order. I'm going to do second quit here. I'm going to do stat. I would go down to sort and then I could tell it L1 and hit enter. Now this is going to error because I don't have any data in there. Okay, I don't have anything in there. Okay, but it does. That's why it doesn't like it. It would sort it. In order to see it, we just go back to 8.95 and 9.95. So that's going to be the shoe sizes 9 and 9.5. So we have 1, 2, 3, 4. We have 4 data values. 9.95 to 10.95 would be size 10 and 10 and a half. So we count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Are you with me? And then 10.95 to 11.95 is size 11 and 11 and a half. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. Did I count that right, you guys? Let me just double check that one. Okay, and then 11.95 to 12.95. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 12.95 to 13.95. I don't have any in that group. And then I just have 1 in this last group. Now the way we double check this is what should all of these add up to be? That's right. If I have 50 data points, this should add up to be 50. So 20, 34, 38, 48, 49, 50. So it does. If I add those numbers up, they should total 50. And that's just a double check to make sure you didn't miss one. Okay, now the relative frequency, we're going to calculate. Remember up here our formula for that? Frequency, the relative frequency is the frequency divided by the sample size. So the frequency for this class is 4 divided by 20. Okay, so if I see if I can move this over and get my calculator back up. Second quit. Let's do 4 divided by 20. 1/5, right? So it should be 0.2. 0.2. And let's go ahead and do these other ones. 14 divided by 20. 20. Whoops, why am I dividing by 20, you guys? I'm sorry. 4. Divided by 50, right? We're going to divide all these by 50. I'm so sorry. 14 divided by 50. 20 divided by 50. 11 divided by 50. And 1 divided by 50. Okay, so if we take each frequency and divide it by our sample size of 50, not 20, 50, sorry about that. If we take each frequency and divide it by our sample size of 50, that will give us our relative frequency. So we have 0.28, 0.40, 0.22, 0, and 0.02. Okay, now think of these, if we change them to a percent, remember changing these to a percent will move the decimal 2 places to the right. So this would be 8%, 28%, 40%, 22%, 0%, 2%. So they should all, if we have all of our data, it should total 100%, or this should add up to 1. So we add these up to double check to make sure they equal 1. Okay? And it looks like these do. Yep. Those add up to 1. Does that make sense, you guys? So when we do our histogram, the vertical axis can either be our frequency or our relative frequency. Now, what I'm going to show you in a little bit is a frequency polygon, or sometimes we do what's called an ogive, and I'm not sure if we're going to do that here in a little bit, but the cumulative frequency would just, oftentimes you can either add up the relative frequency or the frequency. So if I add these up, this just means 8% are within the first 2 classes, then 0.36, I'm just adding these 2 together. And then 0.76, 0.98, 0.98, and 1.00. And so those add up to 1. You can also do it with the frequency and have 4, 18, 38, 49, and then 50. Okay? So let's draw our histogram now. So we're going to have a vertical axis and a horizontal axis. On the horizontal axis, I'm going to put my boundaries. Okay, my 8.95, 9.95, 10.95, 11.95. Okay, but what I'm going to label them is what my data is. These are shoe sizes. You're not going to put boundaries. You're going to put whatever it is. Okay, on the vertical axis, let's go ahead and do our relative frequency instead of just our frequency. You can do either one, okay? The relative frequency are our decimals here. They go up to 0.4. So we always have to start at 0 here. So let's go by, 0.05, 0.05, 0.10, 0.15, 0.2, 0.25, I'm going to run out of room, 0.30, 0.35, 0.40. Okay? Okay, so my first bar from 8.95 to 9.95, the height of this bar is going to be 0.08. I'm doing the relative frequency. If we had done frequency, the height would be 4. So we would have had to label our vertical axis differently for frequency. Okay, so we're going to go up to 0.08, which looks to be about right here. The second class from 9.95 to 10, so 9.95 to 10.295 is going to go up to 0.28. Remember these, so this is about right here. Remember these bars touch, and then 10.95 to 11.95 is going to go up to our 0.4. And then 11.95 to 12.95 is going to go up to 0.22. And 12.95 is going to be 0. So it's just right here on the axis. And then 13.9 is 0.02. So just right here. Okay, and that's our histogram, our relative frequency histogram. Okay, so what we're going to look at now is different shapes. We want to know what's the shape of this histogram. So we have several different possibilities. We have symmetrical or mound shape, and usually we kind of think of a smooth curve over this histogram. Symmetrical or mound shape looks kind of like this. If we could draw a smooth curve, symmetrical means it's a mirror image on both sides, so my curve isn't perfect here. Okay. Uniform or rectangular would be if our bars were all the same. Okay, so it looks like a rectangle. Now, skewed left basically means all our bars would be clustered on the right-hand side and they would trail off to the left. This would be left skewed. Skewed right would be if our bars are clustered here on the left, but they trail off. So it's the way they trail off is where it's skewed. This would be skewed right. And then bimodal would be if we had two high points in our graph. All right, so if we kind of picture a curve over top of this, it would kind of go like this. So it looks pretty symmetrical. It might be slightly skewed, but it does look pretty symmetrical. So the important part of our histograms is to look at our sizes. Now, if we picture this graph on top of the midpoints, went off a little bit here. Let's just say I picture this graph. Oops, didn't mean to lose my line here. Okay, if we picture these as midpoint, just the middle of our bars here, and we connected them with a line, kind of a smooth line, it would look something like this. This is called a frequency polygon. So the frequency polygon is we have the classes, but we attach and instead of the relative frequency, we use frequencies. We attach the midpoints, the middle of the class. So this would be the middle, 54.5 would be in the middle, and there's our frequency 5. So it's like drawing a line on those bars. That's called a frequency polygon. It also shows you, it's a little more rigid, but this graph looks a little bit left skewed of these calculus final test scores. So again, the frequency polygon is a line graph of midpoints of our histograms. Another graph we can do is called a time series graph. And some of you may have seen these already. This is where we have a time, like here we have the years, and we just plot it over time. So right now, some of you may be seeing some time graphs of some of the pandemic that's going on with COVID-19. Okay, any questions so far?